All right, case number one, my kid Kyle. And he's in a master's program at GWU in Washington, D.C. And then he has a girlfriend who's in some sort of internship with a company. And they see each other on and off. It's been finals, so I'm not exactly sure of the continuity of their recent exposure to each other, so to speak. And about, I don't know, 5 days ago, Kyle got symptoms of an infection that I would call systemic. And I'm hearing people call it musculoskeletal, but it's more, the body aches. And he didn't really have respiratory symptoms. And he had GI symptoms and then dizziness and headache. His girlfriend had more respiratory symptoms, although she had some of the systemic symptoms. He went to get PCR testing and got up early. The poor kids, they're afraid to talk to me if they don't do things right. I've got to figure out how to be a little less, I don't know, strict. But anyway, he didn't want to call me until he had gone and gotten tested. He got up early and had to wait in line, but got a test. His girlfriend went to a different place, got a test. She got her result back in 24 hours, and it was positive. He had to wait 4 days, and he just got his test back yesterday. It's negative. And we have to figure out what this means. And they're both PCR, and now, and he was feeling pretty good. Day by day, his symptoms were improving. And then today he developed a sore throat, which is kind of consistent with what his girlfriend had. Now, Kevin, who's on line here, he has a roommate who works at a restaurant. And Kevin has had both of his, Kyle has had both of his boosters. No.
Both of his shots.
Both of his vaccinations, but didn't have a booster and didn't have a flu shot. I think the same is true for his girlfriend. Kevin, on the other hand, has had both vaccines and a booster and a flu shot. His roommate works at a restaurant. He has had both of his vaccinations, but not the booster and not the flu shot. And he just found out he may have been exposed because the restaurant does a really good job. And one of the employees came back positive. So here we have somebody that's exposed, and then somebody that may indeed have COVID. A quick definition of terms. When we talk about isolating versus quarantining, I think that's going to become more and more important. And I would like, it helps to think about things if you know that there's a difference. We call it isolation when you actually have the infection. So you isolate yourself. When you've been exposed, you quarantine. And there is a distinction between those two. And it has to do with, I guess, the incubation period. And interestingly, the amount of time that they had been recommending for quarantining was longer than isolating. And the reason was because they were trying to account for the amount of time it would take for the virus to incubate and replicate and to either and then either cause disease or transmission. And whereas so that was supposed to be 10 days. They added 4 days to quarantining to 14 days. now that may be changing, but the point was this incubation period. Now, it's getting a bit hard to talk about this because now we have some variants running around. And a lot of the data coming out refers to one or the other variants. So can you extrapolate from one variant to another? I would like us to think about viruses as they don't really want to kill the patient because they need to replicate and live. And I like to think of it as sort of, I don't know, something, an alien being coming in and taking us over as kind of a robot. And the idea is to kind of commandeer us, but not kill us. And so we kind of think of the virulence or how severe it is as what the virus wants to do, because we're worried about not doing well. The virus really doesn't, and we refer to it as the evolutionary pressure. The evolutionary pressure is to replicate. And so it doesn't want to kill the host. It would want to be transmitted from one host to another, obviously. And then it wants to evade whatever you do to try to get rid of it. So it would, there's an evolutionary pressure to evolve so that it is no longer captured by our immune system or any sort of vaccine that we might develop, or even any antivirals or anything. That's what happens with, bacterial infections where we get resistant strains, like we hear about staph. Okay. I want to, let's see. I'd like to get across the idea of what the tests are that we have available to us. And it's going to change. I have to say, and I won't go too political, I'm quite disappointed. This is the first time I've been very, very disappointed with Biden. This was a bad decision to not be developing the testing capabilities. And apparently it was a decision. And they did it back when they thought they had gotten rid of Alpha and they were going to do everything by vaccine. I'm somewhat, well, I'm quite supportive of the vaccine, but this wasn't a very, given what I told you that we know about viruses, testing is going to be the cornerstone of anything. So I can't believe they dropped the ball on that. Now, it's not, it's going to be a little while before we have a lot of testing materials available. But I think this session is still going to be useful. We're going to have to figure out how to live with this thing. And testing is going to be really important. I'd like to get across the idea, and it keeps coming up with this pandemic, is when something has linear growth versus exponential. And the test, one test is linear, it's the antigen test right now. And the other one, PCR, is exponential or an amplified. And the way PCR works, and I'm going to buy a whiteboard that I can hold up sometime, but it's really brilliant the way PCR works. And so you have a gene that is, let's see if you can see this, that is a double helix. Okay, that's my double helix. And what a PCR machine does, and what happened, and our genes are, have these nucleotides that are bases, and that's what Watson and Crick figured out, and that's our genetic code, and it goes in sequence, and it only uses 4 letters, but all of our genes are created by the pattern, the order of these genes. And So what PCR does, and PCR requires a machine. And I'll tell you how that works. So you have your double helix. We isolate the DNA from a sample. And you've heard it in criminal evaluation of criminal cases, detection of other diseases. But what happens is that you isolate the DNA, and it can be, and PCR is designed to find a needle in a haystack. So you have it in a little test tube, and what happens is the machine, and it's put in liquid reagents. The machine then heats up, and the double helix separates into two pieces. Okay, it comes apart. And then, depending on what gene you want to look at, we mix in what we call primers. And they are the exact sequence of the gene that you want. And so you cool the reagent, you cool the test tube down, you have the primers in, and a little primer is here and here on either side. Oops, I put either side of the separated fragments. And this is called polymerase chain reaction. And it uses an enzyme called polymerase. It creates a polymer, like we talk about plastic. The chain is by where these primers are placed. It determines what sequence is going to be detected or read. And then you've got the parts of the DNA, the letters essentially in the reagents, and they do their thing and they make a double helix. So between those two primers, and what you put in for the primer determines what you're looking at. So this is hot, this is cold. And then we heat it up again, they separate, they have the primers in there, they do it again. You heat it up, they separate, you do it again. And each time there's a doubling, and that's exponential growth. And the best way I can talk about exponential growth, it's just really, it's a hard concept to get in your mind, but we're going to be living with this. So you might as well get it in your mind, because we've talked about exponential growth of the cases too, but it's whenever it doubles. And let's see what I, and here's what I wanted. I wanted to give a good example. Think of a lily pond, and each lily pod doubles each day, takes 24 hours. The question about exponential growth, when was it half covering the pond, lily pods? 24 hours ago, yesterday. So it shows you how fast, if something's doubling, how fast it can go from something that is quite small to something quite large that's overtaking you. But that's the concept of how PCR works. And that's why it's so sensitive, because of this exponential growth, and it just goes in and grabs whatever's there. There can be almost none of it. And you take it through the cycles of heating it up, cooling it down, heating it up, cooling it down, and you end up with a lot at the end. But you only end up with what you put in the primers for. The antigen test, in contrast, looks at, so this is looking at the gene of the virus, the genome, a part of it, the part we decided to look at with these primers. Those primers were designed by the company making them. The antigen test, on the other hand, is looking at a product of the virus, which is, in this case, a protein. And it happened, well, no, from each test, anyway, let's just say it's a spike protein. And the reason the antigen test is such that it is we have all sorts of dipsticks, reagent strips that we use for other diseases. And and what happens is that there's a chemical reaction that occurs. And so if you're looking for something that is related to the virus, you determine what it is, you have something that binds to it, and then if there is a hit, so to speak, a reaction occurs, and there's a color that is generated, and we call that a colorimetric acid. And that's what you're seeing on the reagent strip. And we've had those for years for different things. And so this was reasonably easy to develop as long as we knew what we were going to look at.
So should we?
No,
we have 15 minutes to where it has to sit. That was just the question of.
Oh, well, okay.
If we started this and then you came back and talked through things while it.
Okay. All right. So what I'd like to say is that this is why you have to go to a lab. You're not going to have a PCR machine at home. And then we have these strips here. And you can see why this would be developed for home. Other types of things are in the incubator in terms of how of different kinds of tests. But yeah, I guess we should proceed. What I would like to say quickly is each type of thing has a control. And with PCR, contamination is a really worrisome thing because it can be amplified. And so you have a negative control where you don't put anything in but the reagents. And you make sure there's not contamination of the reagents. It also has a positive control where there's the thing in it, and you just want to make sure the reagents work. The antigen test only has a positive control, and the reason it's there is just to make sure that the reagents are working.
So this is, and Hurley Jim has one. This is the common, one of the common antigen tests. Common, but you can't get it right now because it's in short supply.
Exactly. And what's sad is that apparently Abbott had a bunch of them. They weren't selling them, so they dismantled them.
So I'm going to do this, and Hurley Jim can follow. And we did this at the San Clemente camping trip. There's an instruction manual in it, and it contains.
Yeah, there's one in Spanish, one in English.
Linda, you can read the Spanish one if you want, but
yeah,
it's got a package with a nasal swab. It's got what you actually stick it in to test it. It's got the reagent, the liquid, and it's one or the other. So I'm going to just take this out and show you. There is a package with the reagent in it, or the strip, and it's interesting. It's a little card. It opens up, and if you can see a blue line right there, that's the control strip that Claudia was talking about. That's
to make sure the reagents are working.
So that's got COVID on it, essentially.
It does.
And so it will turn, it's there to make sure that the little test is working. Below that, there's a blank space, which will turn color if it's positive for COVID. So that
I hope we have no surprises today, but we could.
So in this, and Hurley Jim, there are two little holes here. You open this up and set it down flat, and put the, try to follow this carefully each time. You take this thing that's the dropper that has the reagent in it, puts the top off, and then take the reagent and push 6 drops into the top hole. 3, 4, 6. And set that back down flat. Set the little dropper thing. And then this is the fun part. You have to take the, how do I open this? The nasal swab out. So it's just a little stick with a cotton thing, and you stick it up each nose sequentially, and nostril. Yes, each nostril of your nose, like this, and and you turn it around out.
And I clever to get him to do it.
Oh, and then you have to do it again after your eyes water. If your eyes water, you're probably doing it right. And twirl it at the same time. Oh, okay. Oh, so I'm done. Okay. Then it says, did you swab both nostrils? Yes. Then you take it to this little card. And this is sort of the tricky part. You take the nasal swab with your boogers on it or whatever else is there. You stick it in the first hole. And you slide it forward till you can see it in the second one, and then you twist it around for a little bit. And then what we're going to do is set a timer for 15 minutes. So I'm going to do this.
And so essentially a colorimetric reaction
So I'm starting the timer.
is being initiated.
And there's a little strip on here that is adhesive. So you can take it off. And when you fold it over, what it does is it folds the test strip onto the reagent stuff. Fold it over and squeeze it down. And you'll see that there's a little blue line at the top. Hopefully I'm not going to get a little pink line below that, but the reagent gradually moves up kind of by osmosis, right?
Like a wick.
A wick.
A wick.
From the part that's in here up to there. And
of course you will have the positive control, and it will give a color. And because it has COVID in it, and then the test sample, and if there's COVID in it, then it would be positive. If not, then not. I want to just say.
So yeah, in the instruction thing, there's a little sheet here, and it says this one on the left is you're trying to get. The control wants to be positive. So the control wants to turn pink. That means it's working. The line below it is whether you have any antigens.
Right, and from the virus. So, okay.
So we're going to wait 15 minutes, and Claudia, you can go back to.
Okay, I want to give a few, a little more information, and then maybe we'll look at this and we can have some period for questions.
Yeah. Do you think questions could come at like 2:30 or 2:40 or so?
Give me 5 minutes.
Okay, and then we'll open it for questions.
Yeah.
Great.
Okay. What the CDC put out that first time, and if you recall, way at the beginning, the testing was all screwed up. It was because the reagents were contaminated and they were all positive. Everything came back positive. So they really messed up. What I want to say about the antigen test is it's not very sensitive, or it's not as sensitive as PCR. So you're going to have false negatives. The PCR, on the other hand, is highly sensitive. So sometimes you can have false positives. And then I want to talk about the time frame, and this is now becoming really important. When should you do a test, and what does a positive test or a negative test mean? And it's a lot of the information is very confusing, and most of the information relates to Delta and not the Omicron. And so it's just, I'm sorry, it's distracting to me. So because of the, let's think of the front end of an infection. When should you test, and how do you interpret a positive or negative test? And remember, I talked about before that there's, I think they've been underemphasizing transmission, and you have an incubation period for transmission, and that's going to come in your upper nasopharynx, whereas disease is going to come from the lungs. And what Delta introduced into things was an increased transmission. And what that means is that you can transmit, but still be asymptomatic. And so you can have no symptoms and have a positive test. And generally, when you have symptoms, you would be incubating the infection long enough for a test to go positive. Then the body starts clearing it, and that's when the test goes negative. And you can still have disease, because the disease is really because of the immune system. And so you can have the infection but have a negative test. And it looks like Omicron is going to be quite different from Delta, and it's getting very confusing as to how to interpret things. But that's why it's so, I think this home antigen test is going to be incredibly useful. You just should have a bunch of them at home and doing them sequentially day after day after day if you need to. And the PCR one is very good because it's so sensitive. The only problem is that it detects any fragment of the DNA that's around. And so the DNA can actually not be, or the virus cannot be alive, and you're still detecting it.
Yeah, so you look like you're sick with COVID when you're not.
Right. But, PCR is still the gold standard, and it'd be nice to get that, but we're not going to have that at home. Okay, so there you have it. Does anyone have any questions or cases that they'd like to talk about?
See, Abby had her hand up, and then Daria.
Okay, Abby, shoot.
Is that what you described? Is that the test they're talking about, the government sending us if we ask for it? Is that the one you just described?
The one that I just described, the antigen test, yes, it's the one that the government is talking about sending. They wouldn't be able to send the PCR one, obviously. And the antigen one is going to, there are other types of ones coming out. I'm not going to explain it, but it's called CRISPR, and it works by looking at the DNA again. But they're going to be a reagent strip. So we're going to have things that are going to be better. I want to say one more thing, and I'm sorry I'm so verbose, but there's just a lot to say. This does not tell you which variant you have.
Yeah.
genomic sequencing, which is a much longer process and has to be done by a big lab, that even more than the PCR machine.
Oh, so that's actually a really interesting point, that this just tells you generically have
Yeah,
COVID.
and our government, I mean, Trump in a way ruined it, but our capability for genomic sequencing and knowing what kind of variants we have is really dilapidated. And we're not even distinguishing breakthrough infections, like what variant is in a breakthrough infection versus an infection like in somebody that's unvaccinated or not. So, Abby, does that answer your question?
Yeah, well then suppose it's positive, then what do you do next? Do you do another test to confirm it? Do you call your doctor? Do you, what would be?
The problem is it's evolving, and it really is evolving, and Omicron has sort of taken over. And if it's positive, there aren't many false positives. There may be false negatives, but they're not false positives. And you may make some decisions based on that. Although it used to be said to do a confirmatory test with a PCR. But, and the thing about it is we used to have to get there really fast to use the monoclonal antibodies as therapy. But now, because of the change in sequence, the monoclonal antibodies are no longer helpful. So
I guess if you've been vaccinated and you turn up positive, and don't yet have symptoms?
Okay. And this will take another time, but to talk about the utility of being vaccinated or not with the 2 doses plus the booster. And so getting a positive result in the face of 2 vaccines and a booster, in a way, makes you just isolate because there's not much else to do. When those antivirals come out, and someday I can tell you what those are going to be, they're different than the monoclonal antibodies, you would want to take those. But right now, there's really not much to do, except for you're going to be really glad you got vaccinated and got a booster because you're going to do okay.
Yeah.
You just need to work not to transmit it to somebody else. All righty. Daria?
Wait. Oh, okay. So in thinking about exponential growth, if we want to reduce COVID outbreak, in other words, to reduce the exponential growth that you talked about at the beginning of your lecture, is the vaccine helpful in this regard if and only if we have enough people taking the right amount of vaccines? And by right amount, I mean the 2 regular doses plus the booster.
Daria, I'm so glad you asked that question. And it's a really good question. It's what they base their whole response on. And exponential growth is if every person that got COVID infected another person. So, and that's doubling.
Or 2 people
No.
infected? One?
Yeah, each time. If each of us went out every time one of us got it, we would be doubling it. What the vaccine does is push that down. And it pushes it way down. I mean, it's like 100-fold. So we still get breakthrough infections. We still get all sorts of, but it's way, way down. So it converts it from exponential growth to linear growth. So in fact, yes. And that's why it's so important. Not only, and you hear them talking about mild, moderate, and severe disease. And I'm starting to understand the fights that are going on. The FDA licenses drugs so we don't get sick. Fauci and his group and Biden have to make policy where we try to protect a population. That's why the FDA is saying everything's cool and they're even saying you don't need a booster. Whereas Fauci and Biden and everything, they want to push the booster for the precise question that Daria asked. Okay, Kevin, I think you were next.
Well, my mom kind of had it right from my roommate Andrew. He does work at a restaurant here in Beverly Hills called Spago. And they've been doing a really good job of testing and things. They've started out, 1 day a week to 2 days a week. And they're requiring all workers in the restaurant to wear masks during their shifts, but you can take them off when you're eating or drinking during your break. But unfortunately someone had did take their test and they become positive, but my roommate Andrew is doing fine, but I'm glad to have my booster shot and things. And but this Abbott test is not FDA approved. They're saying that all the in-home tests are not FDA approved, like the
I think this one is, but I guess Kevin, I'd have to check that. But Kevin's example brings up an important thing. This is exposure. So the thing we're talking about is quarantining. The problem is, and you've heard about them wanting to bring back essential workers after 5 days. The problem is that's based on the length of time that Delta sticks around, and there's clearing of that. Omicron may stick around longer. And we don't even have data on it. And when Omicron becomes positive, when it becomes negative, we don't even know. I still think that the testing is useful, but the timing of it is.
So this,
Oh, okay. Anyway, let me just finish. The timing of it is a real problem. But you would quarantine under the previous thing, you'd quarantine for 14 days. Now they're saying you should quarantine yourself with an exposure for 5 days and then wear a mask. Then that becomes a whole discussion about what is a protective mask. Now, Kevin would not be the one that's exposed, but he has a roommate. And but he's highly protected because he's got the vaccine and the booster. All right, well, were you next, Joanne?
Yeah, I think so.
Oh, we're gonna do the result. I'm sorry.
so my timer went off, and Claudia, it's
negative, right?
it's negative, thank goodness. So
Good.
you can see,
Do you bring it close to the?
I don't know if it can.
So you
focus.
see the top line, that's the control, and the bottom line
There's
is
no line.
blank. And so it's either a true negative or it's a false negative.
Because
And
it's not detectable.
if you're really suspicious, you should do it tomorrow. And if you're still suspicious, the next day. And many people get upset. Why do I have to do that? Well, any test has a false negative rate. And if they would make these cheap, and if we could feel like we could do this like brushing our teeth in the morning, then we would know a whole lot. I really, really like these home antigen tests, even if there's a problem with their sensitivity.
And Kevin, you're correct. On the back of the box, it does say
good
has
for you.
not been cleared for FDA or approved, but has been authorized by FDA under an EUA,
Oh, the
emergency use authorization.
All right. Well, Kevin, good for you. You
Good.
got your mom.
Well, I mean, I always knew it was negative. Well, I mean, I know it was always not FDA approved because I've been reading that online, and
No, you're following
Good
it.
for
That's
you.
good.
Yeah,
That's
got
good.
you, Mom. Okay,
So,
Joanne?
Joanne?
Yeah, I just wanted to ask your opinion, Claudia, on what I saw on the streamer on CNN this morning, how they run the news across the bottom, on the stream. And they were saying that the CDC is now saying that if you test positive for COVID, but you are asymptomatic, you do not need to quarantine. You do need to wear a mask if you go out, if you're with other people, but you don't need to quarantine.
Do you ever hear Kavita Patel talk? I love her. I am quite concerned about that, and that's based on the CDC stuff is based on the Delta virus. And okay, here's what I want to say: the concept I want to get across. Delta introduced the idea of increasing transmission versus the virulence, how sick you got, and disease. That was the game changer that made this pandemic so hard to get rid of. I think it's been underappreciated and under talked about. And Trump tried to hide that there's asymptomatic transmission. I'm a little worried we're going right back to what Trump did. And we're going to have, there's a viral load that can cause transmission, but not disease. And I think transmission is the game changer that makes it, from a population point of view, or to our children who can't get vaccinated, a problem. And so I really think that the FDA is only talking about what you do to prevent disease from mild to severe. I really think we also need to be talking about transmission. And I don't actually think that this 5-day thing en masse is adequate for that. So that's my long-winded opinion.
Isn't Delta was twice as transmissible as that first
It was
Alpha,
more than that.
or more than that. And Omicron, they think, is the same. It's exponential,
Yeah.
like you were saying, to Delta.
And you can see why there'd be evolutionary pressure to increase transmission. And so I would like to see, as we hear people talk, but I would like to hear policymakers take into account, and you could almost do it separately, transmission versus disease. And then, this is the back end of the infection, and how fast you clear the virus. We need to be really sure about that. And I'm not sure we're as sure as we should be.
Yeah, and Omicron, is not at all looking like it's as serious as Delta at all in terms of lethal. So
I think you're right about that, Joanne. And I think the data, except for we don't really know, and this is a little bit upsetting, we're not really tracking, we really don't know how it performs in unvaccinated people.
right.
Okay, Linda, please.
Well, there's a whole lot here. And I think it's very helpful. One of the things that I think was helpful in all of this to me is to think about the at-home test being understanding why the at-home test would be more likely to have a false negative, and the PCR test to be more likely to have a false positive. And that was very helpful to me to sort of try and sort that out. And I've had a lot of both in the last year. I've taken a lot of tests and had one false positive on a PCR test and a major freak out event, which as soon as I got it, I got back in line and got another one. And anyway, it was a major panic mode. But anyway, so I think that's helpful. The more I understand the science, which is pretty, I won't say I understand very much, but the more you understand the science, the better off you are. And so, I mean, I just always, appreciate that. So then when you see things like all of a sudden you only need 5 days instead of 10 or 14 or whatever, with no actual indication that those decisions are made following the science, then you have to figure, then you have to ask, why are decisions being made that don't follow the science, right? And to what extent is this about, politics and profit? And when you get into that situation where folks who really want it, like me, who really want to follow the science, see the decisions are being made that don't follow the science, I think that really sort of it sort of poisons the atmosphere, right? When you're trying to argue for science and people are like, yeah, man, but look at that. It makes it very hard to have this argument, because it doesn't seem like the policymakers are following the science.
Well, Linda, first of all, I'm really glad if I could get across one thing, getting across what the difference between the PCR and the antigen test and this exponential versus linear, it's going to come up over and over again. So if that's one thing you guys got from it, and then I really want to get to how simple it is to do the antigen test. And if we had a bunch of antigen tests, what I would do instead of the 5 day is make sure the antigen test at home was negative, and then you can go out. The PCR that has a few false positives. And I'm so disappointed in what Biden did. They apparently made the decision to not go after the War Powers Act or whatever it is to support testing. So stupid, because they apparently did it after the alpha virus in July, when they decided they'd won thing. That's like Bush going out on the ship and say we won the war, and that they dismantled their
Mission accomplished.
Mission accomplished.
I could go on and on and on. This is going to destroy confidence. Bad decision. That if we had home testing in plenty, can you imagine how different the decisions will be made? And all I can say is, once it comes out, you guys are going to be ready to do it, and you can see how you can lead an ordered life if when you brush your teeth, you do your COVID test.
Okay, so my next question is, and I do want to be sensitive about time. You mentioned, Claudia, that finding the exact variant is not possible. So my question is, what needs to happen to get clarity on which variant we're seeing in the tests? And if we find out what variant is present, does this then change our strategy moving forward towards reducing the COVID numbers, thereby getting us towards a linear growth versus exponential?
I'll try to give it really quickly. To find out which variant it is not tied right now to the patient. So when you get a PCR test, it is not paired with a variant test right now. And the way to find the variant is to sequence the whole genome. And that's very lab and labor intensive. That is why we are developing, and let's take science, and it was part of the Human Genome Project. And the guy, Francis Collins, who led the Human Genome Project, it was introducing ways to do large-scale sequences of big things in a pooled way, so that you can then indicate that something's going on, that you need to do all the work to sequence. So there's not an easy answer. What we're doing right now that I think is really cool is when they go and take samples from sewers, and they literally, and it's the pooled sample from your neighborhood, And if it shows up by the sequencing of the stuff in that sewer sample, then they start looking, they tighten up their contact tracing, and then that's how you do it. But it's not an easy answer. We got some cool stuff going on.
So Claudia, where do you get the tests that you have there now?
Well, okay, so until a month ago, these were sort of easily findable online, usually online, but at CVS, I've gotten them both at CVS and Walgreens. Now, if you go online,
To Amazon?
even to Amazon, and there's a couple of other brands, I don't know how good they are, you can't get, the delivery dates are in January. So
I want to agree with that.
Oh, you got one?
Because I have data. I have Amazon Prime, and I have ordered these. I've ordered these because I try to follow the science, and I had people over at my house, and we've done these a lot. And what happens with Amazon Prime is when I order these, they say the delivery date is way down in January, and then they show up in 36 hours.
Oh,
wow.
really? Oh, that's really good to know.
No, well, that's why I'm sharing this.
Yeah.
I even interrupted.
No, that's good to know.
Sometimes you really got to share this. So I don't know.
Yeah, I found that with Amazon too, that most
Okay.
often they're earlier than they say they are.
This one, these said that the delivery date would be somewhere like in January 6th through 10th, and they showed up on Saturday. The 20th.
Try that, Claudia.
And not all,
They showed up on Christmas Day or something crazy. I mean, and so we used them all up because, that's how we roll. And we've used them all up, and I ordered some more, and they said they'll show up on December 10th. And then I got a thing from Amazon saying they'll be delivered tomorrow.
Okay.
So I want to encourage people to, if you have Amazon Prime in particular, and I would say a lot of us,
Yes, I have.
that was what we were going to do during the pandemic, so we didn't have to go to Target, to go on Amazon Prime and order them, and I don't get a kickback from Amazon here, but anyway, so they do show up sooner than promised, and that's been my experience 3 separate times.
Oh,
So
and not
so
all,
I'll try that.
and not all the tests are the exact same. The antigen is different. It's not even spike protein on in each one, and they're going to evolve. I just think these, having them at home. Well, Linda, you can probably tell us how much it has changed your life to be able to do that.
we had a number of people over here. How many do we finally have, baby? 12? Anyway, to celebrate winter solstice. And that's just how we rolled. I said everybody had to take a test on Sunday. And then everybody had to take a test on Tuesday before they got in the car. Well, before my sister got in the car. And we all did it. And then, we were also very careful. We didn't eat from a common plate, which is how you're supposed to eat Ethiopian food. Everybody had their own injera and their own food on the table on their own plate. When we were in the house, we had the doors open and the fan on. We zoomed outside. We were super careful. And we lit a fire in the backyard and sat around the fire and drank whiskey. But we actually celebrated the winter solstice with my brother-in-law, who was really worried, really didn't want to come. You can't convince, Carmen and Chloe's mother of anything. So I'm not even going to try. They didn't come over, but what are you going to do?
Okay,
Right.
I'm going to interrupt. It's 2:57, and there is another meeting after this at 3:15. And
Louise, thank you.
Thank you.
okay, and thank you so
guys.
much, Claudia. And I hope we do it again. And this was great.
And I want to finish with one sentence. You know, having you guys, I know this was a little bit science dense, but having you guys as part of the community, you're going to talk. And I think it really supports the greater community. So thank you for lasting through this.
Yep, thank you.
Thank you. Thank you.
All right. Bye-bye.
Bye.
Thank you.